MCQ type problem from group theory. Here 4 statements are given. We have to find out the statement which is not true. That is, we have to find out incorrect statement. Right? The first statement is the set given by this is not a group. It is obviously true, because if it be a group, then it follow the closure property. But with respect to plus 2 plus 3, this is 5, this is does not belongs to S. So with respect to plus, this is not closed. And similarly, if we operate this operation with respect to multiplication, then also we get 2 into 3, this is 6, this is also does not belongs to S. So this is not a group with respect to addition and multiplication. Okay, so this is correct statement, because it is given that this is not a group. Now in the second option, a group with 3 elements is necessarily abelian. We know that if order of a group is 3, 3 is prime, and we know that group of prime order is cyclic. Okay, so G is cyclic. This means abelian, because any cyclic group must be abelian. Okay, this is abelian. So we say that group with 3 elements is necessarily abelian. This is also correct statement. Okay, and option number 3, Z plus is not a quasi group. Okay, now we first know what is quasi group. Here we already write down the definition of quasi group. G circle is said to be quasi group if for all AB belongs to G, A composition X, this is equal to B, and Y composition A, this is equal to B, has a solution in G. If these two equations have solution in G, then G circle is said to be quasi group. And an important note about quasi group, we write here, every group must be quasi group. Okay, and we know that Z plus is a group, so it is obviously a quasi group, because we know that set of integer with respect to plus is a group. So it is must be quasi group, but it is given that it is not quasi group. So this is the incorrect option. Okay, so our answer is option number C. And we see the last option, the set of all complex number Z with mod Z, this is equal to 1, is a group with respect to multiplication. It is obviously correct, because we know that all the complex number with unit modulus must form a group with respect to multiplication. So this is also correct option. And our statement which is not true is only C, and C is the answer of this problem. Okay, very interesting problem of group theory. Thank you for watching.